What if your DNA could be used to hack your emotions? Not in some distant sci-fi future, but now through the intricate, invisible code inside you that determines whether joy comes easily or if sorrow lingers just a little longer than it should. There's no chip to implant, no serum to inject, just your own genes quietly shaping how you see, feel, and even remember the world. This isn't theoretical anymore, it's science. Real people, real genes, real emotional consequences, and it's changing how we think about happiness, trauma, and everything in between. Back in 1872, Charles Darwin Darwin published a book called The Expression of Emotions in Man and Animals. It was groundbreaking at the time, not just for cataloguing emotional expressions across humans and other animals, but for one radical idea: emotions might be universal and possibly tied to our biology. This wasn't just about smiling or frowning. Darwin was beginning to pull at a thread, one that would unravel a whole new understanding of the human experience. Fast forward a century, and in 1972, psychologist Paul Ekman took Darwin's theory even further. He argued that there are 6 basic emotions that are universally recognized: happiness, sadness, fear, anger, surprise, and disgust. These are hardwired into us from birth, he said, no matter what culture you come from. It was a bold claim, but one that's been backed up by decades of cross-cultural research. Still, there was one question Ekman didn't answer. If these emotions are universal, why do some people feel them more strongly than others? This is where things start to get personal and genetic. Scientists began wondering, could some people be genetically wired to experience emotions more vividly, to be more susceptible to joy or to trauma? And could those emotional tendencies be inherited, passed down like eye color or height? One of the most compelling answers came from a series of studies involving identical twins. Now, these aren't just any twins, they were separated at birth and raised in completely different environments. Same DNA, different lives, perfect subjects for testing nature versus nurture. Researchers put them through a battery of tests, measuring everything from intelligence to emotional well-being. And despite growing up apart, many of these twins displayed strikingly similar emotional profiles. In particular, their levels of happiness, or what scientists call subjective well-being, were remarkably alike. This wasn't just coincidence. The conclusion: happiness has a significant genetic component. Your ability to feel joy could, in part, be written into your DNA. So what genes are actually involved? One of the first to be seriously studied was COMT, which encodes an enzyme called catechol O-methyltransferase. This enzyme helps break down neurotransmitters like dopamine, epinephrine, and norepinephrine, key chemicals that influence your mood. In a 2014 study published in the Journal of Affective Disorders, researchers looked at 445 people and found something fascinating. Those who had a specific variant of the COMT gene, where valine is replaced by methionine at position 158, a change known as Val 158 met, tended to be more grateful, more forgiving, and overall happier. They also had lower levels of depressive symptoms. This tiny genetic difference was giving them a leg up in the happiness department. But COMT is just the beginning. In 2016, a massive study published in Nature Genetics took this investigation global. Researchers analyzed DNA from nearly 300,000 people and found 3 specific genetic markers, called SNPs, that were linked to higher levels of subjective well-being. These SNPs were found in genes called RAPGF6, CSE1L, and NMUR2. What's interesting is that these genes are active not just in the brain, but also in places like the pancreas and adrenal glands organs that play a role in hormone production and stress response. Scientists believe these genetic variations might affect how the body handles stress and anxiety, which in turn could influence how happy or unhappy you tend to feel. But what about the flip side? Are there genes that make you more vulnerable to negative emotions? In a study published in Frontiers in Human Neuroscience, researchers found a genetic variation in the CD38 gene, which influences the release of oxytocin, the so-called love hormone. People with a specific SNP, known as RS3796863, were more likely to feel alienated from friends and family and had higher rates of suicidal thoughts. Their emotional well-being was clearly impacted, and it was tied directly to their genetic makeup. Still, none of these discoveries explain how these genes influence emotion on a day-to-day basis. What's the actual mechanism? This is where the story gets even more intriguing. Rebecca Todd, a neuroscientist at the University of British Columbia, decided to find out. In a study recently published in the Journal of Neuroscience, she focused on a gene called ADRA2B, which affects the neurotransmitter norepinephrine, a key player in attention and emotional regulation. Previous research by Todd had shown that people who carried a deletion variant of this gene paid more attention to negative words. But she wanted to go deeper. What was happening in their brains? Todd scanned the brains of 39 participants, 21 of whom carried the deletion variant of ADRA2B. The results were startling. Those with the variant saw emotional images, both positive and negative, as more vivid. Their brains lit up in regions responsible for emotional evaluation and regulation. This wasn't just about feeling things more intensely, it was about literally seeing the world differently. Todd called this phenomenon emotionally enhanced vividness, or EEV. In the experiment, participants were shown emotional images that had been pixelated or noised and asked to estimate how much distortion they saw. Carriers of the ADRA2B deletion variant consistently saw less noise on emotional images compared to neutral ones, indicating that their brains were tuning in more sharply to emotional content. This heightened sensitivity wasn't just a subjective feeling, it was measurable, and it was deeply rooted in their DNA. And this sensitivity has consequences. Todd suggests that people with this gene variant might be more susceptible to PTSD or intrusive memories after trauma. Their brains simply can't ignore emotional information, it stands out too clearly. But there's a flip side. In situations where emotional awareness is crucial, like creativity, social interaction, or even detecting danger, this gene could be an advantage. Todd even pointed to the French novelist Marcel Proust as an example. Famous for his richly detailed, emotionally charged writing, Proust once wrote an entire 7-volume memoir inspired by the simple act of eating a Madeleine cookie. Todd believes he might have been a classic deletion carrier, someone whose brain was finely tuned to the emotional essence of every moment. The story doesn't end there. The ADRA2B gene variant isn't equally distributed around the world. In Canada, roughly 50% of Caucasians carry the deletion variant. But in other populations, it's far less common. For example, a study found that only 10% of Rwandans carried the same variant. This opens up fascinating questions about how culture, environment, and genetics interact to shape our emotional lives. Future research aims to explore how ADRA2B and similar genes affect emotional processing in different ethnic groups. Scientists also want to understand how these genes relate to conditions like anxiety, addiction, and PTSD. Could targeting these genes lead to new treatments? Could we one day design personalized therapies based on your emotional DNA? Recent discoveries show that emotions don't just come from your genes, they can change them. This might sound like science fiction, but it's epigenetics in action. Scientists are now proving that emotional states can switch genes on or off in real time. It's not just about feeling bad, it's about how your emotions literally reprogram your brain and body. In one landmark study, researchers found that people suffering from depression or PTSD showed completely different patterns of gene expression in key areas of the brain, especially those linked to stress response. These changes aren't permanent, but they matter. Emotional distress triggers the body to methylate genes, essentially tagging them to either activate or stay silent. This process is especially active in the brain's limbic system, the very area that manages your fight or flight response. What's even more surprising is how early this can start. One study, funded by the National Institute of Mental Health, found that certain genes can predispose someone to PTSD, but those genes were only turned on if the person had experienced childhood abuse. In other words, trauma acts like a key, unlocking dangerous emotional patterns stored in your DNA. Gene expression studies using DNA microarrays, also called gene chips, allow researchers to watch this happen in real time. For instance, medical students facing high-stakes exams showed changes in 24 stress-related genes when compared to their baseline from 9 months earlier. Their anxiety wasn't just in their heads, it was written in their genetic code during that stressful moment. These epigenetic signals, triggered by emotions, affect not only mood but physical health. Depressed or lonely individuals have altered gene expression tied to immunity, making them more vulnerable to illness. Your emotional life, quite literally, is shaping your biological destiny. It's a tempting idea, and one that could easily be misused. If your DNA can be used to understand your emotions, could it also be used to manipulate them? Could marketers, governments, or even hackers exploit this information to influence how you feel, what you buy, or how you vote? Right now, the technology isn't quite there, but the science is moving fast. Genetic testing kits are already available for under $200, offering insights into everything from ancestry to health risks. It's not hard to imagine a future where emotional profiling becomes part of the package. Want to know if you're genetically prone to happiness or at risk for depression? There might be a gene test for that. And once that information exists, who controls it? Who has the right to access your emotional blueprint? These are the questions we'll need to grapple with as the line between biology and identity becomes increasingly blurred. Your emotions, those raw personal experiences, may not be as private as you think. They could be traced back to a few key genes, a few critical variants. And in the right or wrong hands, that knowledge could be powerful. Let us know your thoughts in the comments. Would you want to know if your DNA is shaping your emotions? Would it change how you see yourself or how you experience the world? And if you had the chance to hack your emotions, to dial up the joy or silence the fear, would you take it?